Okay, so programming exercise 5 actually is a lot like the first exercise, where we were trying to search for the largest of three odd numbers. In the initial assignment, we asked the user for specifically three values and then just found out the larger one. In this one, we're going to ask the user to enter a series of positive integers. So we really don't know how many numbers the user is going to type in. And they're going to tell us that they're done once they type in a -1. So unlike the first example where we were dealing with, we tried to deal with negative numbers as well. In this circumstance, as soon as the user types in any value less than 0, we'll stop. So we can only we're only going to consider positive numbers. I'm going to borrow a lot of the code from P1 actually, or at least kind of copy it over and morph it into what we want. That's kind of a valuable tool. A lot of times we can start with a program that's somewhat similar and we can make small adjustments. So I copied in the program that just asks for three individual values. And now we're going to have a program that asks for any number of values. And the trick a lot of times when we need to repeat things over and over again is to find a way to make the statement or the sequence of statements that we're going to repeat to actually look exactly the same. So I'm going to start with that because I've got three variables that are named different things. And then I've got three if statements that they really look pretty much exactly alike other than the fact that they have different variable names. So first off, I'm going to recognize that when I'm using this if statement, I'm actually not looking at any y or z value. It's actually irrelevant, and it's not necessary to have even asked the user for that value yet. So I could have very easily rearranged this program just a little bit to actually ask the user for the second and the third number after I've done the if statements. So I want to stress that right now, this is just example one. I haven't changed anything. I've initialized my maximum odd. I've just changed a little bit of the order, and I'm being careful in that I have not, I don't use y in any of these statements here, so there's no reason why I can't go get it from the user afterwards. If I did use y, of course, I couldn't then go ask for it afterwards. And just to kind of prove that, let's just run that over again. This is our new example, and I'll still get the right answer. So now I want to try to look at this. Well, how can I make all three of these statements exactly the same? All three of these kind of blocks look exactly the same. Well, certainly the prompt, instead of enter x, I can say enter a positive integer, -1 to stop. And that could be the same each time. And the other thing that I can recognize is that the actual variable name doesn't need to be different in each one of these steps, right? So there's no reason, once I've processed x, for instance, I don't use x afterwards in the program, right? There's no reference to x ever again. So there's no reason I can't reuse it. And so I'm going to do that as well. And I'm going to be careful that I change all the references to x. So by the time we get to this location in code line 7, we've already handled the first input. So there's really no harm whatsoever in reassigning x. And I'm going to do that here. Okay, so if we run that just to make sure that we've caught all of those references, looks like I need to adjust my prompt a little bit. I forgot the colon and the space on the last one. It looks like I missed one, right? So, the Z mod 2 needs to be X mod 2. Z is not defined. So let's go ahead and correct that. Very important to run your program frequently. It's much easier to correct and find bugs if you've only made a couple of different edits, right? So like I'm able to kind of really quickly figure out, oh, I misnamed something, or I missed that change of a reference, because frankly that's the only thing that I did in between times that I ran this program. So it's really not a guessing game. A lot of people will go a very long time. They'll write lots and lots of code between times that they run their program, and that's generally a mistake, because if you do 15 different things and then you run your program and something goes wrong, you need to figure out which of the 15 things had a mistake in it. I generally try to run my program anytime I do anything of any significance. And in that way, I can go back to it immediately and know, well, if something goes wrong, it was something that I did 30 seconds ago. And it's much easier to debug your programs like that. So let's run this again. Okay, looks good. And now I can make the final, sort of the final change here. This statement is exactly the same as this statement and this statement. And if I want the user to keep going and over and over and over again, I don't want to just go around 3 times. I want to go around until they type in some negative value. So first off, I'm going to have to actually initialize x. So I'm going to initialize x to 0. It's not an odd number, right? It's going to be smaller than every other. Well, actually, it doesn't. I'm not going to really compare it. So it's going to be it's not a negative number, right? That's the most important thing. And now I'm going to say while x is greater than or equal to 0, I'm just going to do this. I'm going to ask the user for a value. If it's greater than max odd, put it in to max odd. I don't need these rest of these statements. So let's run that. So I typed in -1, notice I stop. Okay, so that looks good. You should always test some of your special cases. One special case is where I don't actually type in an odd number. We know that technically should print out, well, that should print out there were no odd numbers. But if I run that, notice that it comes out and says the largest odd number was -1. And that's a little tricky error that you don't necessarily see in some of the test cases. But let's think about why that happened. My while loop is asking the user for a positive integer. If the user types in -1, -1 is indeed odd, right? If we mod by 2, I get 1. It is also greater than the maximum odd value, right? The maximum odd value is initialized to -infinity. So the -1 does pass this test if maximum odd was never updated. In this case over here, 5, 7, 3, maximum odd was not -infinity by the time I typed in -1, so the -1 was discarded. But over here, 2, 4, and 6 are all even. So maximum odd was still -infinity. That's a problem, right? And we can kind of, if we print this, right, max odd, so we can say max odd is currently, and a lot of times it helps to print things out to visualize this, and max odd is now. I can really get a sense for how this is changing. So if I do 3, we see max odd is currently -infinity, but now it's 3, 5, or 4, 5, and then -1. If I type in 2, 4, 6, notice that because they're not odd numbers, -infinity is always what we're seeing as max odd. As soon as I type in -1, and there's my bug. Right? So there's a number of ways to do this. I could say if x is greater than or equal to 0, and it's odd, and it's greater than the maximum number. Right? If I run that, 2, 4, 6, we can see that it never changed. There were no odd numbers. All right, so that'll work perfectly fine. Another option would be to actually update max odd and make it 0. And in that case, my -1 would not be bigger than it. Either one's perfectly fine. And there's probably a couple of different ways to make it work. So you'll notice that actually in this example, it's a bit fewer lines of code than example 1, but it's actually much more powerful, right? And we're seeing the utility of using our loops.